Hello viewers, this is Wagdaruna taking you through the story of for O-level physics paper 2, and this video we're going to go through the solutions for the physics paper of test 2 on the topic of linear and non-linear motion. So this topic is suitable for students in both senior 3 and senior 4. So let's start with question 1. Question 1 part A, Roman 1 says, what is the difference between speed and velocity? So velocity is the rate of change in displacement with time, while speed is the rate of change of distance covered with time. So now we shall go to part A, Roman 2. So Roman 2 says, sketch a velocity time graph for a body experiencing a net force of 0. Now when force is 0, we know that force is equal to ma. Therefore, if F is 0, A will also be 0. Therefore, acceleration of the body will be 0. And when acceleration is 0, it implies that the velocity is constant. Therefore, the velocity time graph they want is a velocity time graph for constant velocity. So you come here and draw. First of all, put the axes, label them. Then you can draw a graph for constant velocity. So that was part A. Now we shall go to part B. Part B says the graph in the figure shows the variation of distance with time for a body. Describe the motion of the body. So this is distance and this is time. So in the first 8 seconds, the body starts from rest and moves with a uniform speed of 37.5 meters per second for a distance of 300 meters for 8 seconds. So where is this one coming from? If you look at this, when time is 8, the distance is 300. So what we are going to do to get the velocity, you will say distance over time. Therefore, distance is 300 divided by 8, it gives you 37.5. So that is where the final velocity was got from. Then for the next 16 seconds, the body is at rest and its speed is 0. So the body is at rest because distance is not changing. As you can see here, there is not, the distance is constant, 300, which it had already attained. And in the last 8 seconds, the body moves in the opposite direction back to its starting point with a uniform speed of 37.5 meters per second. So the keyword here is opposite direction, because here it was going in this direction, but now it is going the opposite direction. So that's how marks for this slide would be awarded. So now we shall go to part C. Part C says, a ball is wheeled in air in a horizontal circle as shown in figure below. Roman 1. Copy the diagram and show on it the forces acting on the ball in position A. So we are going to first redraw the given diagram, then we can show the forces. So O will be the center of the horizontal circle. Then the first force, of course, will be the weight, which is mg, weight of the particle. Then you have tension in the string, which is represented by T. Then you have the centripetal force, which acts towards the center. Then you have the centrifugal force, which acts away from the center. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says, explain what happens if the string breaks when the ball is in position A. So if the string breaks when the bob is in position A, centripetal force is broken, and thus the bob flies off horizontally along the line which is tangential to the circular path at position A. Afterwards, the body will fall freely under gravity along the path of a projectile. Why? Because weight acts vertically downwards. So that's how marks would be awarded. So this F1, you don't only stop at F1, you have to come and define F1. T, you have to come and define T. F2, you have to come and define it. And MG, you have to come and define it. That's how you can get those marks. So now we shall go to part D. Part D says the figure below shows dots produced on a tape pulled through a ticker timer by a moving body. So this is it. Initially, the distance in between the two dots was 2 centimeters, and also after some time, the distance between the two dots was 5 centimeters, and the direction of motion is there. The frequency of the ticker timer is 50 Hz. Calculate the acceleration of the body. So the time between two successive dots is equal to 1 over f, which is 1 over 50. The f is frequency, that is 1 over 50, therefore the time is 0.02 seconds. The initial velocity is equal to distance over time. Now the distance, if you look at this, initially this distance between two successive dots is 2 centimeters, so, and the time is 0.02. Therefore, when I convert to meters to centimeters to meters, it will be 2 times 2 times 10 exponent times 10 to the power negative 2 over 0, the time, which is 0.02, to give you 1 meter per second. What about final velocity? Final velocity will also be given by distance over time, and here we realize that the distance between the two successive dots will be 5 centimeters. So you convert to meters to give you 5 exponent negative 2 over 0.02 to give you 2.5 meters per second. Therefore, acceleration will be equal to change in velocity over time for 3 spaces, which will be change in velocity is 2.5 minus 1 over 3 multiplied by 0.02 to give you 25 meters per second squared. So that's how the marks will be awarded for this slide. So now we shall go to question 2. Question 2 part A says define the terms distance and displacement. So distance is the length of path covered between 2 points. What about displacement? Displacement is the distance traveled by a body or particle in a specified direction. So now we shall go to part B. Part B says a vehicle traveling at a velocity of 90 kilometers per hour is uniformly brought to rest in 20 seconds. Roman 1, calculate the acceleration of the vehicle. So now this speed is given in kilometers per hour. The first thing to do is to convert it to meters per second. Let's do that. So converting to kilometers to meters, we multiply by 1000. Per hour to per second, you divide by 600, and in the end you come up with 25 meters per second. Then I'll code the formula, first equation of motion, then substitute final velocity is 0 because it was brought to rest. Initially it is 25, acceleration is what you want, time is 20 seconds. So when I make A the subject, A will be equal to negative 1.25 meters per second squared. So that's how marks for this slide would be awarded. So now we shall go to part B, Roman 2. It says that if the vehicle had originally been traveling at the velocity 90 kilometers per hour for 60 seconds, calculate the total distance traveled before it finally stopped. So here it is easier if you draw a sketch graph first. So let's first draw a sketch graph for that motion. So initially it was traveling at 25 meters per second for 60 seconds, then it started retarding for 20 seconds. That's why there is 80 here. So total distance is equal to the area of this trapezium. So it will be got by a half h, which is 25 here, multiplied by a plus b. A can be this and b can be that, area of a trapezium. Then when you substitute using a calculator, you'll come up with 1750 meters. So most students confuse this word area to the unit here and they put here meters squared, but that is not okay. You have to remember that distance is measured in meters. Then part C, part C says a body is fired horizontally with a speed of 30 meters per second from a cliff 500 meters above the ground. Calculate Roman 1 the time taken before the body hits the ground. So this is a horizontal projectile. So we shall come here and first draw our sketch. The height was 500 meters. Then it was fired horizontally. So that will be the path taken by the body and with a velocity of 30 meters per second. So in the question wants the time taken before the body hits the ground. So there we shall use the formula that h is equal to a half gt, that is for vertical motion. Therefore I'll come and substitute for h, substitute for g, which is constant and distant, so remain with t as the only unknown. Simplify, I'll come up with that, divide through both sides by 5, then put square root on both sides to come up with t as 10 seconds. So that was Roman 1. What about Roman 2? Roman 2 says the horizontal distance traveled. So horizontal distance means we shall consider horizontal motion, and horizontal x will be equal to ut, because horizontally acceleration is 0. Acceleration due to gravity is 0. Therefore I come and substitute for u and for t, then I'll come up with a horizontal distance as 300 meters. So that's how marks for this slide would be awarded. So now we shall go to question 3. Question 3, part A, Roman 1 says, sketch the distance time graph for a body falling freely from rest. So distance time graph will be of that shape. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says an object is released from rest at a height of 0.5 kilometers. How long does it take to reach the ground? So I shall use the second equation of motion and come and substitute This 0.5 kilometers have to be changed to meters by multiplying by 1000. It was released from rest, meaning that initial velocity is 0, t is what we want, then g is a constant and t is what we want. So simplify, you'll come up with this becomes 500, the whole of this is 0, and this gives you 5t squared. Divide both sides by 5 to give you that. Put square root on both sides, we'll come up with t as 10 seconds. So that is how the marks will be awarded for this slide. So now we shall go to part B. Part B says a body attached to a string is swung in a vertical circular path in air as shown in the figure below. So it's a figure. Copy the diagram, copy the above diagram, and on it indicate and name all the forces acting on the body if the body is moving in an anti-clockwise direction. So we are going to first draw the given diagram, then we can be able to show the forces. So that's the diagram. The first force we shall put will be the weight, of course, which will be that acting vertically downwards. Then we shall put the up thrust, which is acting vertically upwards. Then the centripetal force, which is acting towards the center, or we call it tension in the string. Then we put the centrifugal force, which is acting away from the center. So those are the forces acting on the particle. Now we shall go to part C, Roman 1. Part C says a small iron ball dropped from the top of a vertical cliff takes 2.5 seconds to reach the bottom of the cliff. Find, Roman 1, the speed with which it strikes the bottom. So we know that from the first equation, this is it moving downwards, that's why here it is positive. So that means that here the velocity, initial velocity was 0, acceleration due to gravity is that, and time taken is that. Therefore, final velocity will be 25 meters per second. So that was Roman 1. Now we shall go to C, Roman 2. So Roman 2, they want the height of the cliff. So using the second equation of motion under gravity, we shall come and substitute u is 0, t we have got it as 2.5, g is 10, is known a constant, this is 2.5. So when I use a calculator, the value will be 31.25 meters. So that is how the marks for this slide will be awarded. So now we shall go to part D. Part D says the graph in figure 1 represents variation of velocity with time of two athletes A and B. Roman 1, describe the motion of A and B. So this is the motion of A and this is the motion of B. So you come as that athlete A accelerates uniformly from rest for 30 seconds, attaining a maximum speed of 8 meters per second, and then retards uniformly to rest for 20 seconds. What about athlete B? So athlete B accelerates uniformly from rest for 30 seconds, attaining a maximum speed of 10 meters per second, and then maintains this maximum attained speed for 20 seconds. So that was Roman 1. What about Roman 2? Roman 2 says what distance was covered by B in 50 seconds. So distance covered by B, I think we realize that it forms a trapezium, because this is the shape of a trapezium. Therefore, the distance covered will be equal to the area of the trapezium with height of 10. Then A can be this, which will be 50 minus 30, which is 20, and the B can be 50. So let's go and substitute for that in the formula of a trapezium. So that gives you a half times 10 times in brackets 50 plus 20, which gives you 350 meters. So that is how marks for this slide would be awarded. So now we shall go to question 4. Question 4, part A. Part A says a block of plastic and a block of lead, each 0.2 kilograms, are released simultaneously and fall down a well with water to the bottom. The lead block took 4 seconds to reach the water surface. Roman 1. State and explain any difference in the time of arrival of the 2 blocks at the surface of the water. So this is not if, it is of. So we shall say that the block of lead reaches the surface of the water first before the block of plastic. Why? The reason is because the block of lead has a smaller surface area than that of plastic. And as a result, the block of lead experiences less air resistance than that of plastic. So why does it have a small surface area? It is because a block lead has a bigger value of density than that of plastic. Therefore, for the mass to be the same, plastic must have a larger volume than lead. So now we shall go to Roman 2. Roman 2 says, calculate the speed with which the lead block strikes the water surface. So we know the mass and we also know the time. So initial velocity is that, acceleration due to gravity is 10, and the time is 4. Therefore, when you use a calculator, will come up with 40 meters per second. So that was Roman 2. Now we shall go to Roman 3. Roman 3 says, find the distance of the water surface from the top of the well. So using the second equation of motion for free fall, initial velocity is 0, time is 4, acceleration due to gravity is 10, time is 4. Therefore you end up getting 80 meters. So that is how marks for this slide would be awarded. So now we shall go to part B. So part B says the figure below represents the velocity time graph for a ball which is projected up a smooth inclined plane. So it's the velocity time graph. Then they said Roman 1, how far does the ball move in the first 5 seconds? So this is what was given. Therefore the total distance is equal to area of the triangle in the first 5 seconds. So this is a triangle. Therefore, area of that triangle will be the distance traveled, which is a half base times height. So base is from here to here, which is 5, and height is from here to here, which is 2. So in the end, you come up with 5 meters. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says, what is the velocity of the ball after 8 seconds? So there we shall come and look at the 8 seconds, then draw a vertical line to reach the curve, to reach the line, then take a horizontal line this side and read off that value. So when you do that, we shall come up with that. Therefore, you come and conclude that the velocity will be 1.2 meters per second downwards. Downwards because it is negative. So that is how marks will be awarded for this slide. So now we shall go to part C. Part C says, describe an experiment to measure acceleration of a body using a ticker timer of frequency 50 Hz. So this is easily done with the aid of a diagram. So we shall first draw a durable diagram. Then we shall label, that is a friction compensated runway. Then this is the trolley, this is the tape, and this is the ticker timer, and this is the wooden block to get a slope. Okay, so let's start. We shall see that the setup is as shown above. So this segment is what links the diagram to the body of the content. They shall start saying that a trolley with a ticker tape attached to it is placed on a horizontal plane or runway. The compensated runway is adjusted so that the trolley moves with uniform velocity. You keep on lifting. It was originally horizontal, but then you lift it using this wooden block until you get a uniform velocity. The trolley pulls the tape through a ticker timer of frequency 50 Hz, and uniformly spaced dots are printed on the tape as shown below. So before we go to the next slide where the ticker tape is, let's see marks for this slide. So below, this will be the printing. Okay. So using a set of 6 successive dots shown above, distance x1 from A to B and x2 from B to C is measured. Now in this experiment I used the 6. It's not a must that they should be 6. It is you to choose as long as they are uniform. You can say 5, 5 as long as you are consistent with the number of dots. So using 6 successive dots, I think we see 1, 2, 3, 4, 5, 6. Then for the second side, there is 1, 2, 3, 4, 5, 6, like that. So you can use 5, 5, 4, 4, or 8, 8, any. So the time t taken to travel each distance x1 and x2 is given by that. Remember, if their number of dots are the same, then the time will also be the same. Therefore, t will be equal to n minus 1 multiplied by 1 over f. So n minus 1 gives the space between the dots, and f was given as frequency, so in the end we come up with 0.1 seconds. then you shall come and say that average velocity over distance x1 will be equal to distance over time. So distance is x1 and time is this. So we'll come and substitute to come up with 10x1. Similarly, for distance x2 to be x2 over 0.1 to give you 10x2. So before I go to the next slide, these are the marks for this slide. So increase in velocity will be change in velocity, which will be this minus that. And with that I can now get the acceleration, which is equal to change in velocity over average time. Change in velocity is this, and average time, you get time for A to B and for B to C, then divide by 2 to give you this as the acceleration. So that's how you could get the 6 marks. So that was question 4. Now we shall go to question 5. Question 5 part A says, two vehicles A and B accelerate uniformly from rest. Vehicle A attains a maximum speed of 30 meters per second in 10 seconds, while vehicle B attains a maximum speed of 40 meters per second in the same time, that is in 10 seconds. Both vehicles maintain these velocities for 6 seconds. They are then decelerated such that A comes to rest after 6 seconds while B comes to rest after 4 seconds. Roman 1. Draw on the same axis a velocity time graph for the motion of the vehicles. So that means that we need a graph paper. So we shall come and say you shall get a graph paper. Then we use the correct scale for the horizontal. Label the horizontal axis, then also use the correct scale for the vertical and also label it. So after drawing the axes, we are going to show the motion for vehicle A and for vehicle B. So let's start with the one for vehicle A. So for vehicle A, it started from rest and accelerated uniformly until attaining a maximum speed of 30 meters per second in 10 seconds. It then maintained the speed for 6 seconds and then decelerated and came to rest after 6 seconds. So let's first do that. Let's first represent the motion of vehicle A. So it started from 0 and it accelerated uniformly for 10 seconds until it attained a speed of 30 seconds. So what we are going to do, we are going to draw a straight line from here up to there. So let's do that. Then from there it maintained that speed for 6 seconds. So 10 plus 6 gives you 16. Therefore, to maintain the speed up to this time. So we are going to draw a straight line from here up to there. So let's do that. Then from there it decelerated to rest after 6 seconds. So 16 plus 6 will come up with this 22. So we are going to draw a line from here up to there. And that will be the motion of vehicle A. What about for vehicle B? For vehicle B, they told us they started from rest and accelerated uniformly until it obtained a maximum velocity of 10 meters per second in the same time, which is that means in 10 seconds. Then it maintained also the speed for 6 seconds and then decelerated to rest after 4 seconds. So this one used 10 seconds to accelerate up to a velocity of 40. So we are going to draw a straight line from here up to here using a ruler. So let's do that. Then need to maintain the speed for 6 seconds, so we are going to draw a straight line from here up to here. So let's do that. Then it decelerated after 4 seconds, so 16 plus 4 is 20, so we are going to draw a straight line from here up to there. So let's do that. And that will be the motion of vehicle B. Then from Roman 2, they said determine the velocity of each vehicle 18 seconds after the start. So 18 seconds after the start, it means that this 18 come here and then take this side and read off that value. So when you do that, you should draw a vertical line to meet the point of intersection, then take this side. I think we realize that this 18 is at the point of intersection, meaning that this point of intersection, they both have the same velocity. Therefore, we shall come here and conclude that from the graph, the two vehicles have the velocities of 20 meters per second after 18 seconds from the start. So both have the same velocity of 20 meters per second. So that's how marks for this slide would be awarded. So now we shall go to part A, Roman 3. Roman 3 says, how far will the two vehicles be from one another during this moment in Roman 2 above? So they want the distance, so the distance will be equal to the area under the graph. So yeah, let's first see the distance covered by A. The distance covered by A will be given by that, so let's see how it comes about. So from this graph, the distance area 1 for A will be from here up to here, then that is a triangle, which will be base is 10 and height is 30, so the area will be a half times 10 times 30. Then from this, area 2 will be this rectangle, whereby the length is 6 and height is 30, therefore it will be 6 times 30. The next is this one, which is the trapezium. Think, realize it. If you look at it from here to here, then this and that, so that is a trapezium with height as 2, then A is 20, B is 30. So that is where this is coming from: area of a triangle, area of a rectangle, area of a trapezium. So in the end, we shall come up with the distance as 380 meters. What about the distance covered by vehicle B? So still we do the same. Get the area under the graph for B. So let's see how this comes about. So the first one is a triangle. Base is 10 but height is 40. Then second one is a rectangle. Length is 6 and height is 40. Then the last one is a trapezium. Height is 2, A is 20, B is 40. So you come and use a calculator to come up with that value, but they wanted the distance between the two vehicles. So you come here and say that, okay, let's first award marks for this slide. Then the distance apart will be distance of vehicle B minus that of vehicle A. So you come and subtract to come up with that value as the required distance. So now we shall go to part B, Roman 1. So B Roman 1 says the diagram represents a velocity time graph for a body in motion. So this is a velocity time graph. Then Roman 1, describe the motion of the body. And Roman 2, calculate the total distance traveled. So Roman 1, let's start Roman 1, motion of the body from A to B, from B to C, and from C to D. So you come and say that for the first 6 seconds, that is from A to B, the body starts moving with a velocity of 10 meters per second and accelerates uniformly at 3.3 meters per second squared until it attains a velocity of 30 meters per second. That is from A to B. What about from B to C? Then from B to C, the body moving with a uniform velocity of 30 meters per second. Now that maintains the velocity. So here there was the word is. Then from C to D, the body decelerates uniformly with a deceleration of 5 meters per second to rest. So that's how marks for this slide would be awarded. Okay, this one was already marked. Okay, so we shall go to the next part. So now we shall go to part B, Roman 2. Roman 2, they want you to calculate the total distance traveled. So it is equal to the area. This is the trapezium, this is the rectangle, and this is the triangle. So you have to add all those areas. So area AB plus area BCD. So this area, so both of them, if you are keen, you realize that they can form only 2 trapeziums. For example, this is one trapezium and this is also another trapezium. Or you can also add each area independently. But let's do this trapezium and also this trapezium. So this will be the first trapezium, second trapezium, and therefore you'll come up with 390 meters. So that brings us to the end of this video. Thank you for watching, and be reminded that the next test will be now test 3 for senior 2, and therefore if you are not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on test 3 has been uploaded. And also, if you know any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.